Today we're going to talk about theoretical yield and actual yield in chemistry. We're going to start with this problem. This problem asks, if you mix 93.8 grams of PCl5 with 20.3 grams of H2O, what is the theoretical yield of H3PO4? What you need to know, starting a theoretical yield problem, is the balanced reaction, right? And the balanced reaction tells us that the ratio of each part to one another is the same. So the coefficient on each molecule tells us that ratio. In this example, we need to know that 1 mole of PCl5 will go to 1 mole of H3PO4 if PCl5 is our limiting reactant, of course, and we have plenty of H2O. And we need to know that if H2O is our limiting reactant, 4 moles of H2O would give us 1 mole of H3PO4. So to do a problem like this, we would start by finding the moles of each of the reactants, because we need to know what the limiting reactant is. So I'm going to go ahead and throw the math up there for that right now. So now that we have these calculations up here, we know the moles of both. So we can see that we had 0.450 moles of PCl5 and 1.127 moles of H2O. Now, we need to distill this info to find out what is our limiting reactant. We can tell what our limiting reactant is by dividing each by their coefficient. So, we know that to do the reaction one time, we need 1 mole of PCl5 and we need 4 moles of H2O. So, we would divide this by 1, and we would get 0.450 moles. And then we would divide this by 4, and we would get 0.2817 moles. We divide it by the coefficient so that we're talking about 1 unit of them, basically, because we need 4 times as much H2O to make the reaction go one time. So we're going to divide by 4 to see if that's our limiting reagent. And it turns out that it is our limiting reagent. So we know that H2O is the limiting reagent in this reaction. Now that we know that H2O is our limiting reagent, we can use that to do the rest of our calculations. And we'll do them just like we have been. So, we'll come down here and we'll write, if we start with 1.127 moles of H2O, we know that we expected that 4 moles of H2O would give us 1 mole of H3PO4. So we'll use that as our conversion factor. 4 moles of H2O should give us 1 mole of H3PO4. And then we can change our moles of H3PO4 straight into grams using this type of conversion, as long as we know that 1 mole of H3PO4 is 97.996 grams. And that all equals 27.6 grams of H3PO4. And that is our theoretical yield. So, You may notice that I started with 1.127 as opposed to 0.2817. I did that because 1.127 is the moles we're actually putting into the reaction. When we divide by 4 right here, we're doing that just so that we can compare our moles to one another to figure out which one's the limiting reactant. We really want to use the moles that we put in. If we're trying to find our actual yield, or our percent yield, then we'll do this. The actual yield will be given to you in the problem. So let's say our actual yield was 20 grams. Then all we would do is take 20 grams over 27.6 grams, then multiply that by 100 to find the percentage. And so that would equal 0.72 or 72%, which is not a bad percent as far as percent yield goes. Just watch out that the actual yield should always be less than your theoretical yield, because chemistry reactions very rarely come out perfectly. And if you're getting more yield than you expected, you probably did your theoretical yield incorrectly. There's my tips for theoretical and actual yield. Good luck.